In this video, I'm going to demonstrate a process for creating pen plots from a generated 3D scene. This is a technique I've been experimenting with for a while, and I wanted to share it because I think it opens up some fun possibilities. First, I'm going to procedurally create a 3D scene in Blender and render it to SVG. Then I'll show you how I prepare it to be plotted and plot it on my AxiDraw. Blender is an extremely powerful piece of 3D software, which is free and open source. If this is your first time using Blender, you may want to search for some tutorials on navigating the scene before you jump in and try it on your own. When I start Blender, it loads the scene with a cube in it. I'm going to hit X on my keyboard to clear the scene and get an empty canvas. Blender provides a UI for creating a scene by hand, but I'm interested in procedurally generating a scene, so I'm going to switch to the scripting view. What's really fun about scripting Blender is that rather than looking up commands in an API reference, you can just do things in the UI and it will show you the equivalent API call in the top pane. To create a script, I'll click New. The script is just Python code. To interact with the Blender environment, we need to import Blender's Python API, bpy. So first I'm going to create a cube, which in Blender is a mesh. Notice how up here it gives us the Python code to create the cube. We can use this as a starting point for our script. I'm going to copy the code to create a cube from up here by right-clicking and hitting Command-C. All of these parameters have default values, so I'll just erase these, but I'll give the cube a different location. Notice that when I run the script, the old cube stays there. Every time I run the script, it creates new objects, but it doesn't get rid of the old ones. To clear the scene, I'll select all the meshes and delete them. Rather than repeat these steps every time I run the script, I'll just copy the equivalent code to the beginning of the script. Now when I run it, I end up with just the cube created by the script. Since the code here is just Python, I can use a for loop to create multiple objects. I'm actually going to create a 10 by 10 by 10 grid of cubes by nesting 3 for loops. It will take a couple seconds to run because it's creating 1,000 objects. Once it's done, I can navigate the scene to set up an angle for the camera. When I've found the one I like, I hit Ctrl Option Numpad 0 to move the camera to the current view. I should note that navigation in Blender is very numpad-centric. If you have a laptop like I do, you may find it worthwhile to pick up an external numpad. Otherwise, there is a way to emulate the numpad, it's just a bit more clumsy. The camera's framing depends on the focal length and sensor size, which act like those same properties on a film camera. I'm going to play with these a bit to get something I'm happy with. Once I've found an angle I'd like to plot, I'll export it to SVG. To do so, I scroll down on the Render tab and check both Freestyle and Freestyle SVG Export. If you don't see these options, look for Freestyle under the User Preferences and make sure the Freestyle add-on is checked. By default, the render goes into the directory temp. I'm going to set it to write the output files to my desktop so that it's easy to find them. Now, all I have to do is hit Render, and the SVG will be created. Before I can plot it, though, I need to clean it up. The output includes lines that go beyond the rectangular frame. To fix this, let's open up the drawing in Inkscape. Then I'll make sure the page size is US letter, since that's the size of the paper I have. I'll scale the drawing so that it fits within the page. I combine the paths so that I only have one path to work with. Next, I'll create a rectangle the size of the page. I convert this rectangle into a path. Then I add the drawing to the selection by holding Shift and selecting it, and use the Cut Path tool from the Path menu. This breaks the drawing into pieces along the edges of the rectangle. Next, I select all of the pieces that fall within the page. I invert the selection under the Edit menu and hit Delete. Now my drawing is cropped to the page. I could plot this drawing as is, but it would take a while because the line order is not optimized. To show you what I mean, I'll use a command line tool that I wrote called PenKit Optimize to visualize what the plotter would do with this plot. I'm using the NoOpt argument to disable the optimizations for now, and viz output to tell it to make a visualization. All of these black lines are paths the plotter arm would take while the pen is up. Now I'm going to use PenKit Optimize again to improve the drawing order. I'll remove NoOpt so that this time it actually runs the optimization, and I'll name the visualization output something else. As you can see, the optimized version has fewer and shorter black lines, which means that it will plot faster. Finally, I get to plot it. I'll open up the optimized version in Inkscape. I set the page size again because PenKit Optimize doesn't preserve it. I've already set up a pen, so I can just hit plot and away it goes. That's all there is to it. I've been astounded by the creativity of the plotter community with 2D generative graphics, so I hope the techniques I've demonstrated open up some new possibilities for you. I look forward to seeing what you come up with.